Today, we're going to look at how you go about calculating averages. And we're going to look at this because I see these types of questions come up all the time, or they actually show up as problems where users say, something's wrong, my workbook isn't returning what I want. And you get down into it, and they haven't calculated averages or rates or done weighted averages properly. Let's start by taking a look at what all three of these have in common. First, they're all calculations, and you're probably going to hear me say 10 times today that they are calculations, and we want you to calculate the numerator separate from the denominator. And I always tell users, and then do the math, divide the numerator by the denominator. Additionally, the numerator for each one of these calculations is the sum of a measure. Okay, for averages, we sum a measure something like, dollars per order or dollars per day, sales per day, that sort of thing. We're calculating the sum of a measure, and then we're dividing it by a count for that measure. And where users usually get in trouble is determining what that count is based on. Rates are almost identical, except the numerator is the sum of a measure, and the denominator is the sum of a different measure. So we're taking the sum of one measure divided by the sum of another measure. Things like miles per gallon or miles per hour. You take the total number of miles you travel, the total number of hours you spent, miles per hour average. Okay, and then a weighted average takes a look at values or records that have different weights. They're not all the same weight. And I'm going to show you how to do weighted averages, and they come in very, very handy. Let's start by taking a look at what you would get when you just use the average aggregation function. And you can get that here. You just open up the green pill, come down to measures, and it's right here on average. Default is sum, but you come right down to average and you get the average. And it appears right here. It's the average sales. But what is that number actually? We know that the numerator has to be the sum of a measure. That's the sum of sales. And the denominator is a count. It's a count, and this says count of orders, but that's not really what it is. It's the count of the total number of records that make up those sales. And I'm going to show you how you can prove that to yourself. I'm going to open up this calculation. It's a very simple calculation. All we're doing is we're taking the sum of sales and we're dividing it by the count, and we come back with the same numbers. And you say, okay, Jim, we know that those are the same numbers. We know that this is the sum of sales divided by the count of those records, but that may not be what you want. Typically, what the question that's asked, or the business question that's asked, is we want to find out the average order size. And if we take a look here, I've got another calculation where we're going to count the number of orders. Now, this first number here, this 232, is the number of records that went into these total sales. And that's the number we looked at on the previous page. That's 232. But if we count the number of actual unique orders using a COUNT-D function, we see it's only 228. And if we take a look over all the records that are in the Superstore data set, we see it makes a very significant difference, because while the total sales are $2.3 million, and the total number of records are 10,000 records, or a little over 10,000 records, there are a little over 5,000 unique orders. Now, if you think about how that happens, a unique order is like an invoice, if you will. Okay, and the unique records are like the line items on the invoice. So you could see you could order something, and you could have a number of line items, a number of different products that fall into different categories and different subcategories. And that's why the number of records is going to be a whole lot more than the number of actual orders. And you can see here in this example, the average per order is 455, which is very different than the average per each individual record, 228. So the first thing we learned here is that when you're calculating averages, you're going to sum a measure, and then you're going to divide by a count. And you, as the analyst or as a business analyst, have to determine what it is that you're going to count. Are you going to count the number of records, or are you going to count the number of orders? Now, a typical example that comes up, users want to see what the average in a category might be versus the average in a subcategory. And you can do this a lot of different ways. These could be dates or whatever, but I'm just using category and subcategory here. And let's take a look at how this is done. We can take a look at the average by category, and that's this orange line here. And we're taking with this the numerator, which is the sum of the measure. And the measure that we're looking at here is the sales at the category level. So I used a fixed LOD, and I said for each category, sum the sales. And then that's going to be my numerator. And I want to take the sum of that and divide it by the count. And we're going to count the number of records that went in to that sum. And that's fixed category count D, as we just saw, the number of orders. And that will get us those 3 bars. And we can do the same sort of thing on subcategory to calculate the average per subcategory. I just do this so you can read it better. We take the average sales, we're taking the sum of the sales divided by the sum of the count. And we get the values that you see here. So as an analyst, or as a business analyst, you need to decide what it is you're going to sum. What is the value that you want to total that's going to be your numerator? And then separately, what is the value that's going to be the denominator? What is the business question you're asking? In this case, we wanted the average per category or the average per subcategory. And that's the key word here. Whenever you speak it out loud, you say, oh, I want the average per category. That will tell you how to determine the count that you're going to use for the average. Up till now, I've been looking at orders and we've been doing order counts. We can do the same thing with dates. You know, average per day is a pretty common value that people look for. And we can take a look at the data that we've got here, where we just take a look at the average sales. And this is that simple average that we first started looking at. That's just nothing more than the aggregation coming out of Tableau. And it says, oh, the average sales in January were $275. But that's obviously not what we want. We want the average per date. Now we get back to the question of what date do we want? We can start with the distinct count of order dates. How many days in January were actual orders placed? And there were 24 days in January where there were orders. And that formula, taking this number and dividing by the 24 days, is 1,844. But that still may not be the average that you want. The average that you want may actually be based on the total number of days in January. Just because you didn't sell something on a day doesn't necessarily mean that you don't want to count that data. As a business analyst, that's the sort of decision you make. Well, to get that number, there are several different ways, but this formula will always return that number. All this does is look at the order date, looks 1 month in advance of the order date, takes the first date of that month. So for January, this part of the formula will return February the 1st. We back up 1 day to January 31st, and we take the date part of day of that, and that's 31 days. So when we use that to calculate our average, once again, we're going to take a numerator, which is the sum of a measure. We're going to take a look at each month separately. Date trunk is going to break those sales down into months. We're going to take a look at the sum of the sales in each month and divide it by this number, which is going to be the 31 days or the 28 days in the month. And we get an answer that looks like 1,428 for the 31 days in January. So let's talk about averages for just a second. As a business analyst, you need to decide what it is you're going to take the average of. You want the average sales, for example, you're going to take the sum of sales, and that's going to be your numerator value. My recommendation is that you calculate that separately. Then determine what your denominator is going to be. Okay, in this case, we wanted the average sales per every day in the month. So we had to write an expression to come back and return the number of days in the month, and then divide the numerator by the denominator. We're going to move on to rates now. And rates are very much like what we've been doing with averages, just one difference. And when we look at rates, we're going to take the sum of the measure, just like we did for averages, but we're going to divide now by the sum of a different measure. We've been talking like miles per gallon or miles per hour, that sort of thing. Here, we're going to take a look at that same Superstore data, and we've got some returns that go into that Superstore data. And we're going to take a look at the return file, and what I'd like to do is I'd like to calculate a return rate. Okay, and we know here in the case of bookcases, for example, the total quantity ordered were 878 bookcases. But 66 of those bookcases were returned. Now I'd like to calculate a return rate. I'd like to calculate this number, the number that was returned, divided by that number, the total number that was sold. So let's take a look at how we go about calculating that number. There are two different measures that we're going to use in this calculation. The first is we're going to calculate the number of returns. Okay. And this is another LOD. We're just taking a look by subcategory, and there's a reason for using an LOD here. We're going to take a look by subcategory. We're going to take a look at what was returned, and we're going to just return the quantity. And that's that value right there, 66. Okay. And then we want to divide that by that 878. Well, we're going to use another LOD to calculate that value. And it's a very simple LOD. All we're going to do is say by subcategory, for each one of these subcategories, what was the total quantity sold? And that's at 878 value. And then we're going to calculate that rate by dividing the numerator by the denominator on quantity. And we get this value. And I'm going to just break this here so it's easier to read. In the numerator, we got the sum of what was returned, that value, divided by the total, that value, and we get 6.45. Okay. Now, our formula here is going to calculate that over all the individual subcategories, and then when we take a total, the fixed property here is going to take the total over all the subcategories divided by the total of all the sales, the total return divided by the total sales for 7.87. Now, you may have noticed here that I can do this on two different levels. And I can do that based on dollars, or I can do it based on units. We went through the calculation that took the 66 units that were returned divided by the 787. We could have done the same thing on a dollar basis. You know, the $7,000 or $7,400 divided by the $1,500. And obviously you're going to get a different number. So you as an analyst have to know what rate you want to calculate. It's the return based on, or the return per quantity sold, per unit sold, or per dollar sold. Once again, it's, if you say it in words, it's you're going to take an average or you're going to take a rate per some measure that you're going to use in the denominator. Now, up until now, we've been assuming that all the records have the same rate, same weight. And that's not, while that's true, sometimes it's not always true. Sometimes values or records have different weights, and then you want to do a weighted average. And the weighted average formula is very similar to what we've been using. The numerator is the weight times the value, and then you divide that by the total weight. And I want to take you through an example here, and this is just some made-up data. In this data, I created a spreadsheet that I just loaded in. I'm looking at a number of loans, and the loans were created for different purposes. Each loan has an ID, and there's a loan amount and an interest rate. This is very typical of data that you might see. And what I'd like to do is I'd like to calculate the average interest rate over each subcategory and over each overall, but each subcategory. And I know the value is not 179, and that's just taking the sum of all those numbers, and that's not right. And someone will say, well, just take the average of those numbers. And you can say, well, okay, fine, I can take the average of those numbers. And 6.39, and while that looks like it might be right, I'm going to show you that it's not right. And I'm just going to change this back right now. Well, let's do it this way. Okay. I'm going to show you that it's not right. What I want to do is calculate the weighted average. Well, what do I mean by weighted average? We take a look at our formula again. Our formula says take this weight and multiply it by the value that you want to find the average of. So we're going to take our weight, which is the loan amount, and we're going to multiply it by the interest rate. And if we were to look here at this guy, there's an interest rate of 6.95, and the weight here is $95,000. You bought a very expensive new car. Now, somebody else bought a different car and got that same rate, 6.95%, but the value there is only $20,000. So the weight for this first example is 5 times the weight for this other record. So we want to calculate the weighted average and not the individual average. Well, if we go back to our formula again, the formula says we'll take the weights and multiply them by the rate. And we're going to do that right here. We're going to take, we're going to take the weight, which is our loan amount, and multiply it by the rate that we want to expand this thing to. And that is going to be our numerator. And that just happens to be the interest rate in dollars, okay? So we're calculating that value right there. And then we want to come back and we want to divide that by the total weight. Okay? And to do that, we're going to take our numerator, which is the interest rate in dollars, and we're dividing it by the sum of the loan amounts, or the individual weights. Okay? And we get a value that looks like this. Now I'm going to put this back in here. This interest rate is our base data. And you say, hey, Jim, that's the same value. I got the interest rate. All you did was you took this value, multiplied by that value, and then to get this, and then you divided it by that. You're just going back and forth among the same values, which is true until you get to the totals and the subtotals. Now, when we get to the subtotals, we're going to take the total of the interest rate, that's the sum of the numerator, divided by the sum of the denominator, and that average, or the weighted average, is 6.54. And the total weighted average over all those loans is 6.49, not 6.39 like we initially saw. Now, the beauty of doing this with LOD expressions is that it'll calculate the subtotals and the totals for you. And also, they're totally portable. I don't need to have that chart. I can look at the individual items, individual rates, and the weighted averages independently. Well, that's what I wanted to cover off with you this morning. If we think about averages, we think about rates, we think about weighted averages, they're all pretty much the same thing. And I want to leave you with this thought. Whenever you have to calculate an average, think about calculating the numerator separate from the denominator. The numerator is going to be the sum of a measure. The denominator is either going to be the count of a measure or the sum of a different measure, and it's going to return the average for you, or the rate for you. Thank you very much. Everything you saw this morning has been captured in a blog that's sitting out on my blog, jimdehner.com. And this workbook is downloadable off of my Tableau public profile, and that's the address for the public profile. These are all linked together. If you just remember to go up to jimdehner.com, you can get to my blog or to my Twitter account or anything else. Thank you very much. Hope to see you next month.